Hello everyone. For the experiment number 8, I am going to explain the assignment 1. This assignment 1 states that you have to draw a graph between the error and the derivative of the error. And the corresponding simulation model or Simulink model has been provided. You can see this is the input R, this is the output Y. So obviously this is the signal which is R minus C, the error. So we have connected a workspace to store the data of the error during the simulation. Similarly, the same signal passing through the derivative block is going to store the derivative of that signal, and we have named this workspace as E dot. So, and you may ask that why suddenly we are drawing a graph between the error and the derivative of the error. The answer is hidden in the statement of the experiment title, which says that study the effect of nonlinearity using phase plane plot. So for this assignment 1, there is no nonlinearity added. That later on assignment 2, 3 and 4 we have added the nonlinearity, but before the studying the effect of nonlinearity in the system, we would like to know that what should be the corresponding plot of a linear system before we add any kind of nonlinearity in the system. And the phase plane plot says if we draw a graph between a state and the derivative of the state, it is a phase plane plot. So if we assume the error is a state, so the derivative of the error is another state, and drawing this E versus E dot is going to give us the phase plane plot. Let's go to the Simulink model. I have constructed this beforehand. Now let me show you the block parameters for the step. Don't forget to make the step time 0 unless and until it is mentioned. And for this workspace block, variable name should be stored as E dot, and the save format is, first we wanted to make it in time series. For this E workspace, the save format is in time series. Apply OK. See the XY graph parameters. The xmin, xmax, ymin, ymax values are given. We are not going to alter it first. And this is the simulation time, which is 10. So what we are going to do is first simulate. Once the simulation is completed, the XY plot has been popped up, but as you can see, the graph is not very clear. That is, the shape of the graph is not very clear from this plot. So what to do next? Let me show you. Coming to the MATLAB command window. So I am going to see the plot. This is the error plot starting from 1 and converging to 0.5. I would like to ask, or I would like to explain why the starting value is 1, because I have given a step input, so where magnitude is 1. So if I write R minus C, at the very instant my input is 1 and the output is 0. So first instant 1 minus 0. So if I calculate error, it should be r minus c. So 1 minus 0 should be 1. Now see the plot starting from 1. Now if I plot E dot, this is the E dot plot. So whatever value you have, if I take the derivative of that values of E, I am going to get the value of E dot. Next, our objective is to draw the plot between E and E dot. So I'm going to write E comma E dot. The interesting thing is I'm not able to plot E versus E dot. It is showing some error. Now let me show you why it is showing the error. It is saying that convertible to double, this. So I have opened the workspace. Clicking on the workspace, as you can see, E means I have a 2-column data. Starting time is 0, ending time is 10, up to the simulation time. The data is stored. Similarly, if you see the E dot, the same thing. Now, if I give this plot E comma E dot, it is not valid. It is not possible for plot command to plot, because E is a double column variable as well as E dot also a double column variable. So what we can do is squeeze the data. So x1 equal to squeeze E dot data is going to store only the required data or only the error data. Similarly, x2 I'm going to squeeze E dot data. Now if I write plot x1 comma x2, so where is my plot? Yes. So x-axis is E, y-axis is E dot. Now if you closely observe, the x-axis, x minimum is 0.4, maximum is 1, y minimum is -7, and y max is 1. Close the figure plot. Moving back to this, I have the xy graph. Now set the data. X min was 0.4, x max was 1, y min was -7, y max was 1. Now apply this. OK. Now in addition, I am going to store the data in an array format. Apply OK. Similarly for this array, OK. Now simulate this. Now if I simulate, hold on. Yes. So if I simulate, now the plot, xy plot, that is E versus E dot, is visible with the actual shape. If I go back to the MATLAB command window, now this time I wanted to plot E This is the error plot. Now I wanted to plot E dot, where it is, yes, so it is the plot E dot, and if I wanted to plot E comma E dot, sorry, I have to give figure 3 and plot so this is the 3 figures. So I'm closing the XY plot. So this 3 plot we have. So as you can see now, previously in the time series, the x-axis timestamp was up to 10 because the simulation time was 10. But now it is dealing with only the data stored. So we have the number of data, only plot is between, not respect to the time, it is only the number of samples, and we are plotting the data with respect to number of samples. So as you can see, I prefer to draw the plot from these two, figure 1 and figure 2, because it is very clear as compared to the time series plot. Now see the most important part. You can see the error plot starts from 1, derivative of the error starts from 0. Now moving to the figure 3, if I ask you what is the starting point of this graph, obviously this is going to be the starting point of this graph, where 1 and the 0 is the starting point, and it is converging to 0.5 and 0. See, 0.5 and 0. So this is the starting point of the graph, and this is the ending point of the graph. So what you have to draw, you have to draw this plot, you have to draw this plot, as well as you have to draw this plot. So this is for the assignment 1.